Hello everyone, welcome to Programming Knowledge. So I again welcome you all to Programming Knowledge. So in today's tutorial we are going to do with bit magic. So we are going to cover some interesting tricks. So let's get started with the tutorial. So for the first case, what we are going to cover, we are going to take an integer n and convert it into binary. So take an integer n and convert it into binary. So let's take int to binary. So we'll take an integer n and we would return str of bin n, and would slice it to the two indices, because I told you in the previous I told you, like, if I take an n is equal to 5 and then convert it equal to s is equal to bin n, and then if I type s, then I would get 0b101. So we would slice this to the two indices, so then we get 101. Okay, so it's quite interesting. But what if this, I'll do this, let me do let me get s. Okay, s is equal to s of 2. Okay, now I have s. Now s is 101. So this simplifies the binary representation of 5 here is 101. So pretty simple. For n is equal to 5, binary, that is s, is equal to 101. Okay, simple. This is very simple. We have s is equal to 101. But if I want to convert this into an supposing this is a binary number, and if I want to convert it back to the decimal value, that for that what I wanted right now is that for binary s is equal to 101, I want an n is equal to 5 output. Okay, so I want this as an output, but how can I do this? Okay, let me take b as a variable, just for a temporary variable, b. Okay, I'll take a as a temporary variable and I'll type int s. Okay, now I'll type a. So, oh, this is an issue. This is the very issue. Here the issue comes. Like, here you can see that if I convert into an integer, so for int s I get an integer of 101, but this answer is wrong. This is incorrect. What I want is, for binary s is equal to 101, I want an integer n is equal to 5, because I want the computer to interpret this as a binary number. I don't want it, because if I want to get for 101, I want an output 5. So what I'll do, I'll take another variable b is equal to int s. Now here you can see by default the base is equal to 10, so it converted 101 to 101 binary string to 101. I repeat, 101 binary string to 101. But if I do base is equal to 2, now I'll get the output as 5. Okay, so here you can see, so def int to bin, this is the integer to binary. Now if we want to convert, define bin to int. So we are doing a vice versa process. So the parameter here will be passed as a string. Now then return int s with base 2. Okay, so we'll define some test cases. While t is equal to t minus 1, we'll take t as an input. T is equal to int input, and then we are going to, what we are going to take, we are going to take an integer n is equal to int input. Then for this, what we are going to do, we are going to type print. We have an integer n, and from that we are going to convert a binary string is equal to int int to bin n, and this would return a binary string, because int to bin would return us a binary string. Then what we are going to do, uh, then we are going to do integer is equal to bin to int bin to int binary string. So this would convert back us to the binary string. Okay, so and then we can print n comma integer, and we can also print n equal to integer. So let's do it. So n integer, I'll print the binary string also. Binary string, yes. So this would be a good output to see. So let's get start with the test cases. Yes, so we have test cases. Let me take uh, uh, three test cases. So here you can see, first I had put the input 7, then now when I printed the values, the first one was a 7, then I got the binary string as 111. Then after converting the binary string to back to the integer, that is the integer value, then I got integer, and then I compared n is equal to integer, that was true. So let me do it for 5. Yes, for first I got n is equal to 5, then binary string is equal to 101. Then I converted back into the integer because I had passed here the binary string. So I had passed the binary string, then I converted back into the integer, then n is equal to integer, that is true. So this was our first program. Now we'll quickly perform another program. Okay, now another program I'll perform, that is the kth bit set. So I would put a comment here, binary to int back. So we convert binary to int. Now we have another program that would define is kth bit set. So this would determine if our number integer n has a kth bit set from the right. Okay, so we'll do, so it will determine if our integer n has a kth bit set from the right. So let me check kth bit n, and we have a formula, if n and 1 left shift k minus 1, this would print set, else print not set. So this would this would print. So what we can do, and before that, print n comma k, and now k bit set from right. So this would program would return the k bit set from right. Then we would I would print this also, print. Okay, so let me have some test cases here. Then we define kth bit. So let me do one thing. I'll do this, n comma k is equal to map int comma input split. Then I would call the function kth bit n comma k. So let me, yeah, so let me take some good amount of test cases, 10 test cases. Okay, for the 5 number, we can see the first bit from right. I said the first bit from right is set. Yes, it is set. The fifth, for 5 number, the second bit from right is not set. It because it is 0. Then for 5, 3, yes, the third bit from right is set. Then for 7 comma 1, it is true. Then 7 comma 2, it is true. Then 7 comma 3, it is true. Then the 6 comma 1, the first bit from right, because in 7 all the three bits were set. In this for the number 6, the first bit is not set. Now for 6 comma 2 it should be set, and for the 6 comma 3 it should be set because the second and the third bits are set. So this is our we did our next program. Now one last program which we can do is a very important one. And what we can do, so okay, what we can do, we can create an array of an integers. I'll tell you. Okay, suppose I have a list of integers. I have a list of integers in which 5 comma I'll first create the array 3 comma 2 comma 3 comma 2 comma 1 comma 5. The numbers can be in any order, but if you observe that every number occurs twice, 5 occurs twice, it can be in any order. 3 occurs twice, 3 occurs twice, 2 occurs twice, 2 occurs twice, but 1 is the only number which occurs only one. Every number occurs twice except one number, which could be any. So okay, which could be any. Every number occurs twice except one number. So let me do this. Every number occurs twice. We need to find the number which occurs only once. Okay, so the property we are going to use, I'll tell you. Let me do 5 XOR 5. Every number with a XOR of itself, 5 XOR 5, 3 XOR 3, 2 XOR 2. Every number with the XOR with itself is a 0, but and every number 2 XOR 0, let me do it. And every number the XOR with itself, the XOR with 0 is the number itself, because, so I'll write this property n XOR n is equal to 0, but n XOR 0 is equal to n. Here you can verify this property. 5 XOR 0 is equal to 5, and 3 XOR 0 is equal to 3. N XOR n is equal to 0, n XOR 0 is equal to n. Okay, for this what we are going to do, we are going to take an array input. Array is equal to list map int comma input dot split. So we have an array, and now we need to define find single occurrence an array. So for that what we are going to do, we'll take a result is equal to array of 0 for I in range 1 to len array, because we need to result is equal to result XOR array of I. Okay, then we would return result. Okay, so this is our next program. So, and now I would call the function find single occurrence of array, and I need to print this value because I would get the value from a return statement. Okay, so here you can see. Now I'll take one test case here, and the test case would be this: 5 3 2 3 2 1 5, and I get the answer 1 as the single occurrence element. So let me take another because 5 XOR 5 would be 0, 2 XOR 2 would be 0, 3 XOR 3 would be 0, but then in the end I would have got 0 XOR 1, which 0 XOR 1 must have satisfied this property, so that is 1. So let me take another input. So one more test case is I'll take every number which occurs twice. So 3 occurs twice, 4 4 3, any order, 2 2 7 6 6 20 10 20 10. Here you can see 3 occurs twice, 4 occurs twice, 2 occurs twice, 6 occurs twice, 20 20 10 10 every element occurs, but 7 is the only number which occurs only once, so output should be 7. Yeah, here it is, the 7 is the output. So thank you guys for watching with this video. I'll catch you in the next tutorial.